principle and how to work simple distillation. What is the simple distillation? Distillation is a widely used method for separating mixtures based on differences in the conditions required. In the simple distillation be used when a mixture liquids are significantly different boiling points. A simple example daily, when boiling water. When the water is heated to boiling produces water vapor. Then the water vapor has placed a barrier. Then the vapor will flow and form water again. Liquids to gas phase, then gas phase condensed and changed to liquid again. This principle is the basis for the simple distillation method. Parts of distillation. The apparatus used consists of three major units. 1. Distillation flask or pot, to heat the mixture and volatilize the components. 2. Condenser, to cool the vapors back to liquid state. 3. Receiving flask or collection flask, to collect the results of the distillation. Parts of the completely simple distillation are burner or heat plate with a stirrer or no. Distillation flask. Three-way adapter. Thermometer. Condenser equipped with the water inlet and outlet water. Vacuum adapter. Receiving flask. The next stage of the distillation process. For example, a mixture of liquid A and liquid B. Liquid A has a boiling point of 70 degrees Celsius. Liquid B has a boiling point of 100 degrees Celsius, or boiling point of water. The initial stage of the mixture is heated in distilling flask. When the temperature has reached 70 degrees Celsius, liquid A will to boil. Set the temperature around 75 to 85 degrees Celsius on the heat plate or burner. To prevent liquid B also evaporate, observe the thermometer temperature of no more than 100 degrees Celsius. Liquid A changed to gas phase A, liquid B remains as liquid B. Gas A rises up past the three-way adapter to the condenser tube. Because in the condenser, the flow of water there is a decrease in temperature of less than 70 degrees Celsius. As a result, the gas phase from gas A becomes a liquid again. Because the position of the condenser tube is tilted, causes result liquid A flow down. This continuously process until a result liquid A pure. For attention. The process effective if the difference temperature not less than 25%. Be careful if the mixture liquid is a flammable material. Stop distilling if the liquid is nearly gone in the distilling flask.
Let's take an example. Separation of acetone and benzene by fractional distillation. As the difference in boiling points of acetone, whose boiling point is 329 Kelvin, and benzene, whose boiling point is 353 Kelvin, is only 24 Kelvin. Their mixture can be separated by the process of fractional distillation, using fractionating column. Let's see how this can be done. The mixture is taken in the distillation flask. Fractionating column is inserted between distillation flask and Liebig water condenser. The flask is heated on water bath. At a steady temperature of 329 Kelvin, acetone distills out, and is collected as first fraction, in the receiver. The vapors of benzene are cooled in the column, and liquid benzene trickles down back into the flask. When acetone is distilled out completely, the temperature starts rising, and the receiver is changed. When the temperature becomes steady at 353 Kelvin, benzene distills out, and is collected as second fraction, in the receiver. acetone and benzene can be further purified by redistillation. Using simple distillation apparatus.
Experiment to grow crystals of copper sulfate. What is crystallization? The process of obtaining crystals of a soluble substance from its hot saturated solution is called crystallization. Crystallization is only a physical change because no new substances are formed during the process. It involves only a change in physical state. Crystallization is used to obtain pure substances from naturally occurring impure substances. Here's an experiment to see how crystallization occurs. Take 100 milliliters of water in a beaker and heat it on a Bunsen burner. When water begins to boil, add about 2 milliliters of dilute sulfuric acid and then a spoonful of CuSO4. Stir the contents with a glass rod. Stir it continuously and add more impure copper sulfate until no more of it dissolves. Fasten a thread in the middle of a wooden stick and suspend in a glass. Stop heating and pour the saturated copper sulfate solution in a glass. Place the glass aside and cover the beaker with the cardboard. Leave the setup for 24 hours. After 24 hours, you will find big blue crystals of pure CuSO4 at the base of the beaker. Then remove the crystal from the glass and dry in warm air.
Centrifugation. The centrifuge is a machine that rotates at a very high speed, and by centrifugal force, substances of different densities are separated. This method is used to separate suspended particles of a substance from a liquid. The process of centrifugation is widely used in dairies to separate cream from milk or curd.
Separation of immiscible liquid mixtures. Objective: to learn the method of separating the components of immiscible liquid mixtures using a separate funnel. Mixtures of liquids can differ based on how easily they blend together. When liquids do not mix together and form a homogeneous mixture, we say they are immiscible. A mixture of immiscible liquids can be separated using special laboratory equipment called a separating funnel. The separating funnel is a cone-shaped glass container with a globe-like top. It has a stopper at the top and a tap at the bottom. Using a separating funnel, let's separate a mixture of oil and water, two liquids which cannot be uniformly mixed. We'll begin by pouring the mixture into the separating funnel. Next, we'll close the stopper. Shake the funnel gently and set it aside for several minutes. You'll see the two liquids beginning to pull apart. Water, because of its higher density, will travel down into the conical part of the funnel. Oil, which is less dense, will float on the surface of water. Now, we'll place a beaker underneath the separating funnel and remove the stopper. We can open the tap and let the water collect in the beaker, closing it once all the water drains out. The remaining oil can be collected by placing another beaker beneath the funnel. Now the two immiscible liquids have been completely separated. Summary: immiscible liquids are those which cannot be uniformly mixed together. A separating funnel can be used to separate mixtures of immiscible liquids.